All right, good morning, everyone. Welcome to EECS2030, Section B. I will be teaching two sections this semester, Section B and G. The Section G will be on Thursday. Just in case, if you missed the in-person class today, you can feel free to go to the other one. They will be more or less coordinated, well, pretty much coordinated, and pretty much the same pace, both taught by me. So today, the goal, we are not going to cover very heavy stuff today. The main goal is to really go over with you about the course, especially the syllabus. I'll show you all the study resources you should really check regularly, hopefully on a daily basis. Anytime I want to keep you posted about any important information, I will send you e-class announcement, like what I did earlier this morning. So please know that for your lab session today, you don't need to go there physically, but you may still go, but I won't be there. Also, TA will not be there, just for this week. Starting from next week, at least the TA will be there to help you with the lab. And myself, I'll try to maybe choose some weeks, which I'll let you know beforehand, to do some demo together with you, just to strengthen your understanding. But for today, please get to the e-class announcement and find out the information about Lab 0 Part 1. You want to get started right away. Okay, I'm going to walk over with you about how important it is for you to keep the pace for this course. I'll try to remind you as often as I can. All right? Any moment, if you got any question, please interrupt me. I don't mind. Okay. All right, just about myself. I don't think I recognize any faces here. It might be the first time you're taking a class with me. So you can feel free just to call me Jackie, most preferred. If you really want to call me Professor, Professor Wang, hey, hi, doesn't really matter. Okay, but Jackie, most preferred. Okay, I'm quite informal, so it's okay. And if you need any advice on the course, please speak to me early. So if you don't feel very confident, maybe from the foundation you're supposed to build from the first year, for you guys, maybe 1022. So please do let me know earlier than later, so I can definitely point to you maybe some extra resources or some extra exercises you should really do. Please reach out to me early. Otherwise, you might actually struggle quite a bit in the upcoming assessment, especially the programming test, which I'll speak about in a moment. All right, so anytime if you want to suggest anything for me to improve teaching the course, I've taught this quite a number of times, but there's always some scope for improvement. So just let me know. Feel free to suggest. All right, so if you're not enrolled in the course, this section yet, I believe it is full, but just in case you still want to get into the course for whatever reason, please assume that you will get into the course eventually. Assume that's the case for now, and you want to send me your name, your PPY, passport, your ID, and also your student number. So I'll try to enroll you at least to the e-class, so you wouldn't miss any important information. So any deadline, any assessment that we set out for the semester, no excuse. Don't tell me that you haven't enrolled in the course before then. All right, so please get started right away. All right, and study materials, I'll talk about it. No extension, good. All right, so guys, I'm hoping that this will be the only time I have to present this slide just about some mutual agreement about how we should really run the class. As I said, I don't really mind being interrupted by any question you might have. I don't mind slowing down. On the other hand, I do expect something from you guys, okay? So let's go over that just hopefully only one time, right? Just get it understood right away. Well, I'm presenting apparently, but imagine that you're presenting to an audience, right? Definitely you will we really appreciate some respect from the audience. So please don't talk, all right? I'm quite sensitive to any noise. Even if sometimes you might be whispering to your neighbor just about some questions, please don't do that. If you really got any question about the material I'm presenting, just shout out to me, please. I don't mind. Please don't talk. And also, if you really have to work on your stuff, I really understand. Maybe as we go through the semester, you might get more and more assignment piled up for you. You may want to work on the lab. You may want to work on other assignments in my lecture. I will really be grateful if you can do it elsewhere. So since you're already here, why not just take the time? You'll find that the way I teach, I don't really try to read off the slides. I really try to work out the problem together with you. So just enjoy the time. In the lecture, interact with me, ask questions, make your visit worthwhile. That's really my best advice for you. You'll find that it will lead you a long way for this semester. Okay, and for your mobile phone, if you really got emergency or some text you have to really return, please do it outside. Try to really minimize using your phone. I'll really much appreciate that. Okay. And right, so that's really the only class protocol that I will really please you guys will obey. Right. All right, so the slides, there will be no required textbook for this course, but my slides are pretty much self-contained. I even sometimes try to create new slides if I find anything that can maybe help you understand more material. You can definitely, rely on the slides pretty much, but if you really want to do some extra reading, I suggested maybe some textbook on the syllabus, which I'll show to you as well. Whether to purchase it or not, it's up to you. All right, so as I said, I will try not to read off the slides too much, sometimes maybe just for the theory definition. But other than that, I will try to just work on my iPad together with you about the examples. All right, your engagement. Ask questions anytime. All right, writing email to me. As I said, I'm quite informal. You can look through the example. I'm not going to bother you too much. Formality is really not necessary, but just some courtesy, some politeness will be much appreciated. You will see exactly what I meant, right? I'm not going to read it out. You can just look at it for yourself, right? And also, I would like to emphasize this. Now that we are completely back to in-person learning, remember, back in those years, we had to do remote learning, all of us. It's quite unfortunate, but now we are back. So I would say I most prefer in-person communication. So when you send me emails about any course material, if I don't respond to you, that simply means, come see me, please. And then I will be happy to help you during the office hour, during the lab, if I show up there, or if you want to make an appointment, feel free to suggest. We can talk, all right? In-person communication. And especially for grading-related issues, I normally don't answer grading-related issues over the emails. So again, if you want to talk to me, please just come. I'll be more than happy to talk. All right, the course information, right? So there are two sites you have to pay attention to. One would be the e-class, right? I'll tell you exactly what you're supposed to look at. And also the lecture site, which I'm going to post the lecture slides, recording, example code, iPad notes, etc. Okay, we'll go over one by one. So the e-class site, you can click on the link. If you're already enrolled, of course. If you're not enrolled just yet, send me an email. I'll add you in to the e-class. Right now, there's not really much to talk about, but, well, by the way, that's instructor view, so you don't see all the information just yet, right? So for now, you just make sure you check the course announcement every day or multiple times a day. I think that'll be great. And later on, you will actually see the instructions for the lab over here. But for the first 2 weeks, we're going to do some review tutorial. So mostly, you will be just following my guidance in the tutorial videos. You will see that when you see the lab 0 part 1 instructions. But starting from lab number 1, roughly about week number 3, you can look at the calendar later. Starting from week number 3, we actually post the lab instructions on the e-class site. But whenever you have doubts, you can always check on the e-class. Not much to say today because we haven't got much information just yet, but we'll add up the information as we go. Okay, so announcement, lab exercises, and also written test. So there will be 2 kinds of assessment. Well, 3 kinds, I should say. One would be like a written test, in which case you'll be multiple choice based on the e-class. But it's not going to be done remotely. You have to show up to your enrolled lab session there and take the e-class quiz under our invigilation, right? That's for the written test. And also we got a programming test, in which case all the machines will be rebooted into the so-called lab test mode, which you might have already experienced in 1022. Right? So we're going to run the programming test as well. But the best preparation for you would be the labs. And also before each test, I'll also give you some practice test. So just for you to get some idea. And for your very first programming test, which is going to happen pretty soon, I'll tell you how soon. Before that, I can also host some maybe mock-up tests for you. So you can maybe sit in the lab, get some familiarity with the atmosphere. I'll reach out to you about all the information. And please check your email regularly. That's so important. Okay. Any questions so far? All right, good. All right, and then study materials. There's no required textbook. So what you want to make sure is you study everything I say in the lecture or anything I assign to you for exercises. Okay. Even though sometimes I may say, oh, you may want to do this. There's no submission required. There's no marks associated with it. But you may still want to do it. It might actually help your learning. And it might just help you do maybe better in the test and the exam. Normally, when I do the assessment, the way I come up with the question is I look at what I have covered so far in the lecture. I try to come up with a question from there. So there'll be no surprise. about the coverage. But of course, you have to make sure you actually understand the materials as thoroughly as possible. Anytime you got any doubts, ask me during the lecture or come to the office hour. All right, so that's the most important site that you actually have to pay attention to, right? So that's a lecture site. You can click on the link, or you can easily Google for that. Okay, I'll just show you very quickly how you can do it. Sorry. There we go. Okay, so you can simply Google, you can Google my name, Jackie, EECS, York-U. And you should be able to go to my departmental site. You can go under lectures, right? So you can see that for this fall 2030, right? That's the site, all right? So this site is going to be updated whenever we got new material. So please always check this one, okay? Let me just go over with you very quickly. So that shows the address of my office in the Lassam building. So second floor, once you go there, take the elevator, turn left, and you should be able to see me there during the office hour. And I also got Zoom, so I don't really have any Zoom office hour just yet. I'll see if I can make time. But if you happen to make an appointment with me over Zoom, let's say, for example, in that case, maybe we can talk over Zoom. But it's not the default. Default should be come to see me in person. I just much more prefer to see each other's face. Okay. All right, so this will be some background tutorial videos, also for like optional additional stuff. So your Lab 0 Part 1 and Part 2 already walk you through all the basics I think you should know from the first year. But this is something just additional. If you want to do something additional as practices and to maybe brush up your foundation, feel free. Optional, but it's very useful. And here is also something that I thought you guys should know pretty well from the first year. Okay, you will see elementary programming here. For example, what is variable assignments? What is casting? How do you cast maybe from double into integer, right? Something like that. So elementary programming and also if then else statements, right? And also loops and nested loops. So these are the background slides I would suggest if you don't really feel confident about your foundation. The first 2 weeks would be your best opportunity to really catch up. Go over the slides and then see any bullet point you don't quite follow. Come to my office hour, we'll discuss. Okay, more than happy to. So that would be something I will assume you feel pretty confident when you come to your very first programming test. All right? So that's the background information. And if you really want to maybe go through some complete iteration for the 1022, which you guys took in the first year, you can feel free to go there too. Maybe you didn't take it with me, but that's okay. It's the same material, the same learning outcomes. I'm pretty sure it will benefit you. Okay. And you will see several documents already there. We got course syllabus, which I'll go over with you. You can click on that. So there shouldn't be any major revision beyond today. But if there's any changes, must be minor, in which case I'll let you know explicitly. But I think according to university regulation, things might still change until the second week. Okay. But normally it wouldn't change, just in case. I'm going to talk about iClicker here, but that's something you guys will have to download on your mobile phone. You may download iClicker on your computer, but usually it doesn't work as well as a mobile phone. But I'll let you choose whichever one that's going to work. Okay. I'll talk about iClicker in just one moment. And also the slides I'm presenting right now is over here. And also the weekly schedule, I'll go over that, just about the different schedule, about different sections, about a lab, I'll talk about it. And also semester calendar, just to give you an idea about when the tests are going to come and when the labs will be released and due, etc. All right, so the material for today is already here. Okay, let me just maybe walk you through a little bit. Might look a little bit more complicated than you might imagine because, as I said, I'm teaching 2 sections this semester. So for you guys, it's actually section B. So that means, so today is lecture number 1. We got 24 lectures in total over 12 weeks, right, for the semester. So we got Wednesday here for section B. And then usually I will update the topics, after the lecture. But for today, I pretty much know what I need to talk about. So I put it there already. And you will see the YouTube icon here. So for you guys, section B will be this left column. Okay, so section B. So if you click on the YouTube here later, it's going to contain the recording for today's lecture. Okay, and then you will see 2 notes over here. the right-hand side is what I call the template notes. For example, if you click on that, it's because I use my iPad a lot, and your fellow student from the previous semester had a very good suggestion. Why don't I just post whatever I'm going to talk about today, right? So for those of you who want to take notes together with me, you can print it out if you want, or you can load it to your tablet computer and do it with me. I'll try to post the template notes for every lecture, hopefully, I would say at least 1 hour before the class, right? So you can always check here. I may not remind you all the time. So just check it here, and then you can download the notes. We'll see how far we can do today, right? And then you will see there's another, the left-hand side here is the actual notes, which I'm going to annotate. You can also look at the annotated version, okay? Choose whichever you like. That's going to help you learn it. And your lab 0 part 1 instructions is right here. It's not behind the E class, right? Only starting from lab number 1, we're going to put the instruction in the E class. And these are the 2 links for the tutorial videos itself. You have to watch all the tutorial videos, take notes, reproduce exactly what I wrote in the code, in the video, and then submit it. Okay, I'll talk about submission in just a moment, once we see the syllabus. And for the review purpose, so these 2 are the required written notes for you to read. All right, I cannot emphasize enough. So one of them is actually about how you can use the JUnit test cases for software development. That's a required framework for you to use both in the labs and also in your programming test. So definitely want to get familiar with the pattern, especially for the starting from lab number 1, and also for your very first, starting from your very first programming test, what you will normally be given is simply empty implementation. You will be given lots of JUnit test cases, in which case you have to create all the Java code from scratch on your own and pass all the test cases, right? So that's the overall expectation you have to make sure you understand from day 1, right? So please read through the first document over here just to understand about this particular pattern over here, how you can infer Java code from JUnit test cases. Okay, number 1. Number 2, we are going to use mostly primitive array, which you learned from 1022. So we're going to see how we can somehow mix primitive array and also object orientation in Java, right? You can build some very interesting software code already by using this pattern here. So this second document here also requires you walk you through some very simple example, which we might briefly highlight maybe in the lecture, possibly next week. So you can also go over that and also make sure you feel comfortable, right? I cannot emphasize enough, guys. These 2 documents, if you don't bother to read them, you might just suffer in the labs and the assessment, okay? They're all there, all right? And the diagram I put over here, I'll try to see if I can get here. It's also quite important clarification between compile time and runtime, which your fellow student also struggle to understand from the previous term. I just added this term over here just to see. If we can get here today, awesome. If not, I'll start with that on Monday. All right. All right, so that's about what's on the lecture side. But you will see that, well, I'll gradually add more and more study resources for you. That's the thing that's required. Okay. Any questions? Yes?
Will we still be using the Eclipse IDE for this course?
Yes, good question. So your fellow student question was, are we going to use the Eclipse? Yes. Okay. Let me put it precisely. Okay. For your programming test, you're actually going to use Eclipse. There's no other IDE you can use. Okay. However, for your labs, you will see that it's going to be participation-based grading, meaning that as long as you can submit your best efforts by the deadline, you get 4 marks. We don't grade it. We don't ask any second question. If you just want to submit something that's not very useful, that's okay. I'll still give you 4 marks, assuming that you're going to catch up with the learning from the resources before the actual test. We're going to be very strict on the test. But for the labs, I don't want to give you any pressure. I want you to focus on learning. After the deadline for each lab, I'm also going to give you some video solution to walk you through in case you need it. All right? So for the labs, if you really don't want to use Eclipse, that's okay. It's not a serious issue. However, I would say your best interest would be you may want to get used to Eclipse IDE, the look and feel, while you're developing the labs. So when you get to the programming test scenario, everything should be familiar to you. Right? Okay? So Eclipse, definitely for the programming test. But if you really want to develop some side project using other IDE like IntelliJ, other IDE, be my guest. No problem. Okay. Yes?
So when you suggest that you leave the required written note, is it before the lecture? Is it after the lecture? Before the lab? When is it?
Okay. So just about the written notes, your fellow student was asking. So I would say, ideally, of course, I only posted this morning. I didn't expect anybody to have read it, of course, not even to open it. Right? I would say maybe over the weekend, if you can, start with lab 0.1, and then go over these two notes. They are not long, but they are very dense. They actually contain lots of useful information. I would say try to finish off these two written notes before Monday. So when we actually talk about the OOP review lecture starting from Monday, you will feel more comfortable. Okay? But normally for the slides, I'll try to, once I post slides, if there's any, you can always feel free to do pre-study or post-study. I'll leave that to you because everybody has different habits, right? That one, I wouldn't force you anything, but I'll just make the material to you as soon as I can. And you take your pick. Okay. If no further question, let's now move on. Yeah, we'll talk about course syllabus in just one moment, right? But I think the studies lecture slide is the most important thing. All right, so the lecture will be recorded. I've been doing it ever since 2017 when I first joined York. So I'll keep doing it, but I just want to give you my best advice. Try not to take it as a replacement for classes. If you think, oh, Jackie posted a recording, why should I go to his class? It will be your call, no problem. But I'm just saying that if you can actually come to lecture and interact and maybe take attendance, I'll show you why attendance could be useful. Okay, I'll show you that. All right, so just come and then try to understand as much as possible. I don't think the idea we talk about in 2030 is really terribly complicated. You know, just lots of details you want to pay attention to. I'm quite detail-oriented, so I'll definitely walk you through all the details you're supposed to know. And some topics you might find challenging, especially once we get to inheritance. I'm going to emphasize a lot about inheritance for this course over here, since it's about advanced OOP. When you want to learn about advanced OOP, you have to know inheritance thoroughly. That's something I'm going to also focus on. But come to the lecture, even though it's only 60%, 70% comprehension, that's okay. That's what the recording is for, right? You can always rewatch the lecture and try to maybe see if you can understand the missing part from the lecture, or just come to me. Ask questions and take notes if you want to. Okay, again, it'll be your call, how you want to use it. All right. Questions? Okay. All right, course syllabus. Let's talk about it, right? Again, if you want to download a copy of the course syllabus, it's not on the e-class, it's right here. All right, course syllabus. If you click on that, you will see a copy of that, right? Let's now talk about the course syllabus. Right here. All right, so it's the same syllabus for both sections, B and G, right? The same. And there might still be changes, but I'll let you know explicitly. Okay, let's see. Okay, course policy, please read it through. There's no point to really waste time in the class. Just make sure you're aware. The only thing I want to say is about what I just said about labs. Okay, let me summarize. As long as you can submit your best efforts, even though you submit something that doesn't pass any test cases at all, I'll still give you full marks. Just make sure you participate, right? Just work on the lab for as much as you can. And there's no idea about plagiarism for the labs. If you want to ask ChatGPT for solution, that's okay. If you want to ask your colleague to help you write a code, that's okay. If you want to ask Jackie, myself, directly for hints, I can also give that to you. Also similar for TA. For the lab, I just want you to make sure you can learn the stuff. All you want to ask yourself is, by submitting this lab and before the programming test, am I able to do it on my own without any external assistance? All right? That's really the most important thing you want to focus on, right? Otherwise, no question asked. So if you submit your best efforts before the submission deadline, you definitely get full marks, all right? Just make sure you submit in time. The deadline will be strict, so please just don't make sure you don't miss it. Okay. Okay, prerequisite, I'm pretty sure you have satisfied that from the first year. And then office hour. Okay, again, I much prefer in-person communication, right? So office hour will be 6 to 7 p.m. Monday and Wednesday. So I'm teaching actually 4 sections in this particular term. It's just a little bit more hectic on my side. I'm really trying to make up the time for you guys. But let's try with this. If there's lots of demand for maybe office hour, I can definitely consider adding more. But let's live with that for now. Okay, so Monday, Wednesday, 6 to 7 p.m. in my office. Okay. Or if you really want to make appointments, in the rare cases, no problem, reach out. Okay, so just about where we are. Okay, and Williams Small Center, right? That's for the labs. So all your assessment, except for the final exam, will be in the Williams Small Center. No exception, just always there. Okay. All right, so section B and G are basically completely the same. The same material, the same labs, and also test with similar difficulty level. Okay. And if you somehow miss maybe the Monday class, you can definitely go to a Tuesday. It will be more or less the same. Okay. And the E class I just spoke about. Study materials, that's a site I walk you through in detail, right? And also we got this additional tutorial if you want to do some extra practice. You can also feel free. And this is just one example textbook in Java. Okay. So there are many Java textbooks out there. I'm not saying this is the one you really want to read, but if you want to read, that's one example. Okay, it's a good one. And office hour, schedule labs, and also TA office hour. So I'm also going to assign maybe some 1 or 2 TAs. They will be kind of standing by. So whenever you maybe have some question in the late nights, or maybe sometime that's outside the office hour or outside the lecture, you can reach out to them. I'll give their contact information a little bit later. Reach out to them. You can maybe schedule some Zoom meeting together with them to troubleshoot your labs. But any issues that's to do with the course administrative side, you should always talk to me. The TA will not be in the position to really give you the authoritative information. Okay. All right, course description. You can read it. Let's not waste time. Let's just go to the material. Okay. But I do want to talk a little bit about the course learning outcomes, just so you guys can know what you can expect throughout the semester. Okay, let's take a look. So these are the 9 course learning outcomes. I can tell you, we are actually not going to cover these 2. So these 2 will be something that you can expect more from EECS2030B, the fundamental data structure, and also 30101, the algorithm, right? That's something you can learn from in the future. Okay. We're definitely going to do recursion, but it will be the final stage, about maybe the final 2 weeks. We're going to talk about recursion, right? I'll also point out to you some extra resources. Linked list, also, we are not going to cover that, right? That's also for 2101. Okay. The most important stuff that we're going to cover will be inheritance. We're going to spend at least 6 to 7 classes on that. And I'm going to be very thorough about what you're supposed to know, the inheritance, not just at the coding level, but also to dive deep into the rationale about why things should really work that way. Okay? So that's something we're definitely going to talk about. Right? So for inheritance, there will be, for example, something called polymorphism and something called dynamic binding. Making no sense to you? That's okay. I'm going to teach you that. All right? We'll get there. Inheritance. Lots of stuff there. Right? And then, so this is definitely this learning outcome number 1. So we're given some API. Basically, API is like a method headers. If you think about what a method header looks like, it contains the name of the method and also either returns something or returns nothing, which is void. Or you may have some like parameters, right, about what inputs you can take. That's kind of the API. So this will be the format we're going to see a lot in your labs and also your programming test. A lot, right? You'll be given some API that you're supposed to implement and also satisfy, and then it is you, the developer, who is going to develop everything from scratch to make things work. Right? And when we talk about test implementation, we're going to use JUnits. Okay? And document, we wouldn't cover too much about it, but document basically, I would say, if you can just comment your code, just to make it as readable as possible, because most likely once you go into the industry as a software developer, the code you write is not only meant to be read by yourself, but maybe your teammates as well. Even for yourself, let's say after 1 month or two, if you want to come back to your original software project and want to make some extension, if you haven't really documented your code well with some comments, even yourself, the author, cannot understand what's going on. Right? So documenting your code is also quite important. That's not something I'm going to emphasize too much, but if you want some informal advice, I can also show that to you. Okay? And we're going to talk about aggregation and composition. So those two really boil down into whether reference aliasing is really allowed. Does that kind of ring the bell from first year, reference aliasing? Okay? If no, that's okay. We're going to review it. All right? We're going to do some, we're going to do some challenging example as well, maybe next Wednesday. So once we dive deep into the review. All right? So reference aliasing is also a recurring theme you're going to see in the lectures and also in the programming tests. Right? But you will definitely see that in the labs as well. Right? All right, guys, any questions so far? Good? Hey, guys. Hello. It's distracting to me. Thank you. I appreciate that. Okay, so that's about the course learning outcomes. Let's now go back. Okay. All right, grading scheme. Okay. So these are just the percentage over here about how heavy each assessment is. I'll talk about exactly when they're going to happen. You will see the summary, the calendar. Okay. So to start with, you can see for your labs. So these are participation-based. So one way to look at that, 5 marks for free, right? As long as you do your learning, do your due part, and make sure you submit in time, assuming that you're going to be responsible for your learning to learn all the stuff before the lab test, 5 marks, all right? There will be 4 programming tests. And for the very first one, which is going to happen pretty soon, but I'm only assigning 2% to it just for you to get used to it. And before your programming test 0, I'm also going to host maybe some mock-up test. So you guys can actually show up and then get a feel about what the programming test is going to be like. And there will be increasing weights for each test until the end. What's the best way to really get prepared for your programming test? Try to really do the labs as thoroughly as you can. And also redo the labs even after you have completed that. All right? Whenever you want to redo the labs, set yourself some timer. Of course, the actual programming test cannot be as long as the actual lab. Maybe set yourself, if you want to redo the lab, maybe give yourself maybe 2 hours as opposed to 80 minutes, right? Okay, so that's the programming test. It's going to be basically JUnit based, right? Which you will see thoroughly in your lab 0, part 1 and part 2. And there will be 2 written tests. So these 2 will be E-class, primarily multiple choice. Maybe I wouldn't talk too much about it because I think that before your first written test, I'll also give you some example questions so you'll get a feel. But it's going to be mostly multiple choices. Sometimes you may have to type some answer, right? Yes?
Will it be done here or in the lab?
In the lab. Okay, so good question. So you can think about for all the assessment here is going to be in your enrolled lab session. You cannot choose which lab session to go for your test. You cannot. So you got to make sure go to your officially enrolled session. Okay, enroll lab session, and of course it'll be William Small Center, right behind the Tim Horton. Yeah.
I'm assuming none of the written tests will overlap on the day of the programming test.
The format are definitely different, but because written tests are mostly just about lecture materials. And for programming tests, they're mostly based on the lab material. Do they really overlap? In some way they are, because conceptually they're all OOP. They're overlapping. right? So I would say before each test, usually about a 1 week in advance, I'll give you some guidance, PDF, so you can take a look about what how you're supposed to get prepared. Okay. Yeah. Okay, so that's about the written test. Okay. And the most important component, of course, is the exam. Cumulative, meaning that it's going to cover everything, right? You can think about everything and make available on the lecture sites. All the concept that we cover in the labs, you're supposed to know before the cumulative exam. And that one there is going to be 50%. All right? Very heavy one. Yeah? I'm telling you in day one, so you may actually want to tell yourself, you want to make sure the best way to really get prepared for the exam is to make sure you always keep up with the materials. Right? You don't really want to think that maybe the actual exam, you still got 1 week to really cram all the information. I can tell you it's not going to happen. All right? Just keep up with the pace for the course. Yes?
For the programming and written tests, are we, like, how long of the lab are we going to be given to write?
The exact length for the test, I still need to confirm, but tentatively, okay? Just tentatively. So I think for the programming test, you're going to be given 80 minutes. Basically the whole lab. We cannot take 90 because we got to always leave 10 minutes. That's the departmental rule. For the written test, most likely it's going to be 60 minutes. Of course, I'll make sure the questions that's there will be reasonable for 60 minutes. Okay? But the exact length I need to confirm, right? But I'll just say tentative. That's what I did for the previous term. Hopefully there's no change. Yeah?
Are the written tests going to be like MCQs based?
It's going to be?
MCQ based? Like
Yeah, multiple choice, mostly. Yeah. So exactly how they will look like, maybe once I give you the example question, you will see. Okay.
For the programming tests, will there be like one question that you'll take the entire 80 minutes? Or multiple?
How about this? I think for the programming test, once you do the lab 0 part 1 and part 2 and do the markup test, you will see exactly what it is like. Yeah. But it's going to be, you can think about it as a single problem. But they will be divided into multiple parts. You got to divide gradually, got to develop gradually for the software. You'll see exactly what I mean. Okay. Yes?
With regards to the test in this case, I want to ask, so if the, I'm trying to figure out how to say it. In the case of, let's say I do part of the test and then part of it works, part of it doesn't. I'm going to guess in that case that it's not a part mark thing. It's
Are you talking about written tests or programming tests?
Program.
Programming, okay. Are there partial marks for programming? Short answer is no, in the following sense. So, programming test. What you were given is a single Java class called starters.java, something like that. And then you will get individual tests. Test number 1, test number 2, all the way to, let's say, test n test cases. Okay? The actual, and then your task will be, you have to develop Java classes from scratch to pass the tests. And notice that I call these the starters. They're only there for the basic. So you're not supposed to really program your Java classes only for these test cases. You will see, I'll give you some example a little bit later. Let's not go too much into detail, otherwise we might just get lost today. So once you develop a Java code, we're going to run every test on your developed code. There will be n test cases in total. Depending on how many you pass, that's your mark. So maybe you pass, for example, let's make it concrete. How about that? So let's say there are maybe 24 test cases in total. You pass maybe 17. That's your marks, 17 out of 24. You can do the math to see the percentage. So failing only one test is not going to let you fail the whole test. It really depends on how many you actually pass, right? However, within a single test, if you somehow make part of the test work, but other part doesn't work, doesn't matter because the same test still failed. So that's what I meant by no partial marks. Okay? And you will see that also, as we try to develop the labs and also the practice that I'm going to give you later. Okay? Maybe when I'll also try to host some review session for your programming test to really walk you through some parts of the solution. Maybe in the review session, I can elaborate a little bit more about the grading scheme. Yeah?
Can you explain the partial mark bit again?
Sure. So partial marks. Okay, two things. Number one, I failed this test. Is it going to make my whole test fail? Not necessarily, because maybe you failed this test, but you passed all the others. You still get very high marks. Okay. However, within each test, there might be multiple parts you have to satisfy. If you only satisfy these two parts, but you fail the final part, but the whole test will still fail. So you don't really get that 1 mark for that particular test. That's what I meant, no partial mark. All right? So once you get yourself familiar about the JUnit test, as we'll see in the lab 0 and all the labs, you will see, right? You got to make sure the whole test should really pass by passing all the assertions in the JUnits. Yeah?
Sorry, do you get a deduction if we have compile time error?
Yes, you do. So your code must compile, okay? So because if your code doesn't even compile, you got compilation error, then your code cannot even be run. So you definitely get some, TA sometimes will try to do some very minimal fixes for you, but not much. So you will also get some penalty by not compiling the code. So we are holding a high standard on you because, you want to be proficient in coding, right? It's an important course. I don't want you to suffer in the subsequent courses, whether you're going to be taught by me again, right, in subsequent courses. I want to make sure your future professor in 2101, 3101 will be impressed by your coding ability, right? That's really my hope, right? All right, so guys, we definitely can revisit about this grading scheme once we get to the actual programming test a little bit closer to the time, right? We can revisit, but just for today, hopefully that's some idea. Okay, grading scheme. Any question? Okay? Okay. All right, so the exam is going to be cumulative, right? It's going to synthesize everything. Okay, you can read the rationale about why it's a substantial exam. And the roll marks, it's pretty standard, 50% for passing. And also 90% for A+, 80% for A, etc., right? So just a standard, okay. And expected weekly workload. I'm just quoting from the official standard from Lausanne, right? So for our 3 credit course, you're supposed to spend 9 to 13.5 hours per week on average. If you can spend around this interval, great. If you spend something much less, good for you. If you have to spend much more than that, don't feel depressed or discouraged. These are foundational course. If your foundation wasn't so stable from first year, this will be the time to fix it. So spend more time on the course. It's definitely going to pay off in the long term. All right. So just some indicator. But if you really feel that you're spending so much time on the course, but still don't see any performance improvement, we can talk. Right. All right. If you miss a test, either it's a written test or programming test, you should really contact me within 2 days, including weekend. All right, contact me, and then to say that I missed the test, what should be the next step, and we'll talk. Okay. Accommodation. For those of you who actually are registered in the university accommodation, so please read through this paragraph over here. Just make sure you follow the steps, right? But I think for your fellow students who are not registered, I'm not going to trouble them today. All right, just please make sure you read it if that applies to you. All right, attendance, okay? So in short, in summary, I will be taking, not today, you guys can install the iClicker maybe after class today. Make sure that's installed for taking the attendance before Monday's class. Next Monday and Wednesday, we'll do some trial attendance. Just make sure everybody knows the flow, and then it wouldn't really count as a final thing, right? We just want to take attendance just for you to know. The attendance itself is not going to be associated with any bonus mark. It's also not part of the grading scheme. That means the following. If you don't really come to the class and miss the attendance, it does not have any negative impact on your grade. It's not going to cost you any marks by missing the classes. That's the bottom line. Okay? However, I really want you guys to come to the class, interact, and also ask questions. I'm going to take attendance. At the end of the semester, once I calculate your roll marks out of 100, I'm going to consider many things. Let's say, for example, let's say the passing mark is like a 50, and your mark is about 47. Strictly speaking, you should really fail the course. However, in this case, I'll look at maybe everyone who's kind of close to the cutoff for each letter grade. I'll try to look at how did you do in the exam, and did you show any improvement in the programming test? Another indicator will be, did you come to my class? Right? So that's your indicator. All right? There's no negative mark. If you don't come to my class, that's okay. It's completely your choice. Right? And there's no like a defined bonus for the attendance either. So it's completely up to you. So if you don't want to take attendance when you are in the class, that's okay too. I just want to give you this particular scheme so you can just show that you actually engage in the course, at least be here physically. And guys, you guys are pretty well, pretty good today. So I wouldn't complain. But I'm just saying, I've been doing this for a few years. There was only one instance where I had to cancel the attendance record for one student because of some disrespectful behavior in the class. But I'm pretty sure you'll be fine. Right? But I do reserve the right to do that in case. But I'll always give you at least one warning. Okay. All right, it's a pretty long page, but please just read it through, just to get an idea. But I think what you guys should do is go to download your iClicker and then enroll in 2030 B and G. Okay? But attendance check, let's say you're in section B. If you missed the class from section B, if you want to take attendance in section G, that's okay. You can take it there. However, taking 2 attendances only count as 1. I don't mind if you count to both sections. I don't mind. But just that, for attendance, for fairness, it wouldn't be counted as twice. All right, so do read through about the instruction for signing up for the iClicker, for this course over here, right? Again, you want to look for this one here. This is the name. Okay, so please install and then get ready. We'll do some trial attendance check Monday. Okay, awesome. All right, we're almost through. Okay, so let's. I think we can go in for another 10 minutes or so, just for syllabus, and then we can take a short break before we talk about other stuff. Okay. Okay, semester calendar. Okay, let's. It's pretty thorough. It's pretty self-contained. Let's just now take a look at here. Okay, your Lab 0 Part 1 is already released. It is due next Tuesday. Also, please get started right away. Right? It's not heavy, but it's time-consuming. Right? You definitely want to get started and put some steady work. So we got Lab 0 Part 1 and Part 2, and also we got 1, 2, 3, 4, and 5. 5 different labs. Okay? And we normally, except for Lab 0 Part 1, it's kind of released because we got semester only start today, right? Other than that, you can assume usually a lab will be due on a Tuesday, and the new lab will be released on a Tuesday as well. In case there's any change, I'll definitely let you know explicitly by some e-class announcement. Your very first programming test 0, 1, 2, 3. It will be, we are here 1, 2, and 3. 3 weeks from now. And then it's actually 1 week after Lab 0 Part 2 is due. All right, so you do have some time to also recap and also get yourself prepared. Tentatively, on the 17th of September, during your lab session, I'm going to give you like a mock-up test. So you can definitely go there, optional, just attend. You can even attend 2 tests if you want, right? Just go there and then get a feel about what the programming test is like. All right, you can definitely look at the different assessment. Programming test 0 and 1. So before the reading week, we got 2 programming tests. Okay. So we got written tests. There will be 1 week after the reading week. Also, we got other assessment, right? They always happen during the lab session, always Wednesday. Okay. And drop deadline will be November 4th. Okay. All right, so any questions? Okay. Okay, let's now go over stuff here. So just tentative coverage, for example. Let's say for your written test over here, you can see for written tests, we're going to cover everything until the lecture in the last week. In this case, it will be lecture 13, etc. But don't worry too much. I will definitely confirm the exact average, the exact coverage 1 week before the test. Just some idea for you. So we wouldn't have to bother too much today. Okay, weekly schedule. So we are here, section B, and then you can go to the, you can also go to the lecture on in section G, that's okay, but it's slightly different pace, could be, right? Also, it's maybe a smaller class size for your fellow student in section G. So completely up to you. And for the lab session, lab attendance, optional. Okay, you only come here if you want to. Sometimes I will do some demo in the lab. I'll definitely let you know the day before. So if you only want to come for my demo, that's okay. You're more than welcome to. Otherwise, if there's no scheduled test, the lab attendance is optional. Okay, but if there's scheduled test, of course you gotta come. Right. Office hour right here. So office hour will start from next Monday. Right. So for today, no office hour. Okay, but if you really want to talk to me, I can speak to you briefly after the class today. Okay. All right, and then let's see topics. Tentative, right? So we'll go through the topics as we go. That's about the syllabus. Any question? Okay, a few more things in the slides. Let me go over them, and then we can maybe take a very short break. Okay, syllabus is done. And then, adapting yourself to the second year. Okay, you know what? So guys, I would suggest, before we take a break, any questions? After the break, we shall talk a little bit more about the course material, a little bit more. Why don't we take a 2 minutes break, or 3, okay? All right, so before the break, we spoke about the course syllabus, so now hopefully everything that's to do with the administrative side should be clear. And let's now go a little bit more into why this course. And today, we only got about 24 minutes-ish. I just want to give you some background and also just about the context for this course, okay? Of course, you're adapting yourself from the first year. It's maybe this got to be your very first course for the second year. For many of my former students, they really find this course challenging in the sense that it's more like a conceptual jump about the expectation, maybe about the materials. But in the first 2 weeks, I really try to give you all the review materials I can craft myself. It's really based on my experience and my understanding about the subjects. So really go through them as thoroughly as you can. It will definitely help you a lot in the later assessment. Okay? Take notes and ask questions. All right, so are you guys still doing Android development anymore? Not anymore, right? Okay. When I taught 1022 back in maybe a few years ago, so what your fellow student back then used to actually learn the Java code through developing some mobile app on the Android tablets. That's what usually we'll have. In the lab session, you got to check out some tablets during the lab session and then program your Java code in the Eclipse and load it to the Android tablets. Kind of fun experience, but we are not doing that anymore. We're going to focus on more. So having some visualization of how your code is going to work is awesome. I'm not saying it's bad, but it's more at the introductory level in the first year. Maybe you try to system the other print line and try to print something to the console. Maybe that's how you maybe show the effects of your program, and maybe that's how you show how you debug, how you find any errors in your program. However, in 2030, you want to lift yourself above that level, right? Whatever, anything that's to do with too visual, when you actually try to see exactly how your program works, is not good at this level, right? Okay, and something about testing. Oh, maybe that's something I should really ask. How many of you have done some JUnit testing? Okay, quite many. Okay, if you have, great. If you haven't, don't feel discouraging anyway. So maybe the starting point in week number 1 may not be exactly equal for everybody. My hope is after the review for the 2 weeks, everybody should be on an equal standing to go on to learn about the stuff, right? That's really my intention, for all the materials for the review. All right, so what you guys really want to get used to about testing your code and see exactly how your code will work is going to use JUnit test cases. So in Lab 0, Part 1 and Part 2, I want you to also focus on something called debugger. Okay? If you don't know exactly what I mean, you will see that once you get to Lab 0, Part 1 and Part 2. How you use the debugger to really find issues in your code is something you want to rely on during the programming test and labs as well. You don't really just want to print out something to the console. It's not going to lead you a long way. Not really. Okay? Okay, for software engineer or software developer, maybe that's something you actually are aspire to, after your graduation. So problems are usually specified just using API about expectation. You'll see in all your labs. So we want to kind of show you each test case is more like a use case. It's just about some scenario to describe how the classes, how the objects will work together. Right? You want to make sure all the scenarios we specify in the test cases will pass at the end. And something about regression testing, which I will elaborate a little bit more formally later. But regression testing simply means you want to maintain a set of test cases. Always, if you want to make any small change to your Java classes, you want to always rerun all the test cases just to make sure you don't really have introduced any additional issues. That's called regression. Just run the test over and over again. And also, you want to learn about how to think abstractly. I would say 2030 might be the very first course I will usually emphasize to my students. Of course, you want to know how to trace the code. But at the same time, you also want to have some mental model about how the objects are instantiated and how the method call are going to maybe be changing the attribute value for the object. That's something you want to be able to visualize yourself. That's really about thinking abstractly. 2030 is only a starting point. Once you get to maybe 2101, the data structure, or even 3101 about algorithm, you have to be able to think abstractly without seeing the concrete code in Java or in Python or in any other programming language. Okay? I will definitely, as we actually work through the problems in this course over here, I will also give you more advice later. And you can look at this video, it's kind of interesting. They kind of show you one example interview at Google. So they didn't really ask the candidate to really write some Java code or Python code. They simply asked them to program on the whiteboard. That's pretty much what you will see me actually doing on my iPad always. I'm given maybe some problem there, or maybe I'm given a piece of code. I just want to show you how exactly that works. That's kind of the proficiency and also understanding you want to have beyond the lectures. Anyway, take a look at the video. That will give you maybe some idea, maybe about your future, maybe co-op interviews. All right, so I know all you guys are CS major, right? But your fellow student in section G, they will be mostly engineering major. But I want to include this slide as well. For your degree, I think once you graduate from CS, I don't think you'll be that straightforward for you to convert yourself into a professional engineer, but they do have some mechanism for you to get a limited license. So maybe for the work you're doing, maybe they do require some engineering expertise. So I just want to mention that very quickly, okay? So in Canada, every province has their own association for licensing engineers, okay? So for here, Ontario, we got PEO, Professional Engineers Ontario, okay? Okay, so it's something about code of ethics. It's really about when you are as a software engineer or software developer, you do have some responsibility for making sure your code, which may be run maybe in some safety critical context, maybe the code is being run in a pacemaker, maybe the code is being run in a nuclear, maybe power generator reactor, something like that, right? In the safety critical context, you want to make sure your code will actually work. So that's really ethics. Otherwise, when you actually develop something that doesn't really work, you will be held responsible, right? Okay, so these are just a list of criteria, right? You guys can read it if you're interested. I just want to show you that for our purpose of this course, we want to make sure you will gain all the knowledge and competence you're supposed to get as a software developer, at least at this level, right? You will give you the knowledge about what's really good Java implementation strategy, and also what's really the good knowledge about inheritance for developing code, etc., right? Knowledge. And competence is really what we will try to build from the labs and also from the programming tests. You want to be able to build something on your own, not just ask ChatGPT. Not the way to go. All right. for your information. So let's say you are somehow licensed as an engineer, and somehow you're involved in some software project that's going to be used in a safety critical context. Let's say at the end of the day, the project is going to be delivered. You have to put your name on the acceptance letter. And let's say the project actually failed very miserably. Somebody died because of your failing implementation. What will be the consequence? If you're lucky, you just get your license suspended. In many cases, in reality, you may want to go to jail because you may have caused maybe some loss of money or maybe a loss of lives. So this page over here just tells you that in a long term, if you really consider licensing yourself for the more serious context, you want to make sure you learn all the knowledge and build all the competence you're supposed to have, right, in the different courses, right? So hopefully 2030 is only a starting point for you. All right, so if you're interested about PEO, Professional Engineers Ontario, you can go ahead, click on the link. Okay, what about this course specifically? Basically, we want to solve problems. So you will see different problems in each different lab. Excuse me. So we got different problems there in each different lab. You'll be given some problem description, and you're just going to develop Java classes and also methods to solve the problems. And there will be two parts for your solution. One will be something to do with procedural programming. So this is the part you pretty much learn mostly in 1022. So just about step by step. You got variable assignments, you got if statements, you got loops, right? But the complication comes when we want to do object-oriented programming. So you think about procedural programming and object orientation, they are two independent dimensions. They're kind of related, they can be put together, but they're not the same, okay? So object orientation is really about how you can program different classes and let them interact with each other. So if you want to program something big, you definitely want to go for object orientation. You don't want to put everything into a single class. You don't want to, okay? All right, so these are the two dimensions we're going to also focus on for the course. And you want to be able to express solution in Java. So of course, when you do your programming test, you definitely have to write valid Java syntax to make sure everything compiles and everything runs. For your exam, let's say, you're going to write something on the paper. We may not be so strict on certain syntax. Maybe if you miss a semicolon, maybe you kind of misspell certain words, that's okay. Nothing big. However, there's no so-called pseudocode in this course. You simply cannot say, I just want to express the idea about my Java solution. No, there's no such thing. You have to write Java code. All right, general tips. You guys can also read it. I just want to summarize something for those of you who might need some just general guidance about success. Important inspiration simply means it's science. So it's really science principle that we're learning. So even though you have spent so many hours on a particular concept, but if you didn't really try to think deep about the subjects, it's not really thorough understanding. So I would say for your inspiration, that's really something you have to find yourself, right? And then if there's anything that kind of trouble you, you don't really kind of get it, of course, don't memorize. That's maybe the point that you want to speak to me. I can maybe help you understand. All right, hard work is important, but not sufficient. All right, so stay on top. Okay, so that's why the weekly, maybe every time over the weekend, it's always a good time for you to think about what have we covered in the past 2 lectures for the week, and then try to think about how everything can be put together. That's exactly the kind of reflection I will require you to show on the exam. So you will see that, so go beyond the lecture. So I'm kind of including links for 2 sites over here. You may have heard about LeetCode. That's actually some very popular website for people to get prepared for programming interviews. It doesn't apply exactly to this course. It applies more to maybe 2101 or 3101. But I think for this course, I'm including that anyway, just in case you want to explore that. The coding bed over here is going to be more relevant once we get to recursion in the final few weeks for this course. Okay, be curious, right? Just be curious about the subject, right? You're here for studying computer science. Hopefully you have some passion about the subject. I do, so I hope you will have the same passion too, right? It's really fun subjects. It's not Nothing about, of course, you have to memorize some principles. You have to. If somebody tells you there's no memorization in computer science, they're lying to you. There's got to be some memorization, but very minimum. So what you're really going to be sure is curious about why things work, and also equally importantly, why things don't work. Okay, always reflect. All right? It's a diagram which I myself pretty much like, which is about the components for success. All right? You guys can also take a look at the picture if you're interested. It's on the slides. All right, that's about it. Okay, guys, any questions? Are you good? I got about 10 minutes here. I'm happy about the time that's left. I think at least we can do one thing. Okay? So starting from next Monday, I'll try to also post the slides over the weekend, just about the review lecture that we're going to do for the OOP. We'll definitely start with that on Monday. I'll make all the materials available to you. But I would like to talk about one or two things for the remaining 10 minutes. Okay? Number one, I want to talk about the software development process, especially the distinction between compile time versus runtime. Before I dive into details, can anybody tell me, how do you distinguish between them? Compile time and runtime. Yes?
Compile time is when the IDE gets your high-level language code into something the machine can decipher. And then the runtime is when it's actually running in the machine.
Yeah, pretty good, I would say. So I think your fellow student pretty much catch the essence of that. So compile time, let's do some annotation here. So compile time is really about writing the code. So writing the code in some IDE. By the way, do you guys know what IDE stands for? Integrated Development Environments, right? IDE. Eclipse is just one of them. IntelliJ is another one, okay? So when you are typing your code in the Eclipse, as soon as you save it, it's going to try to compile that to see if you got any kind of errors. Can anybody give me some typical compilation error? Just give me one. Syntax, I agree. For example, you may have spelled the keywords wrong, right? Rather than CLASS for class, you may say CLAS. It's not spelled correctly, right? Very good. But I would like to say one thing more. Syntax error. For example, it could be missing the semicolon, or maybe spelled CLAS, right? Rather than class, right? Just an example. That means you simply got something, like you think about like writing an English essay, like writing a program. What would be a compilation error, like a syntax error, if you spell some words wrongly, right? Another one, but usually syntax error when you're learning a new language is quite easy to overcome. I would say if you're learning a new language, after maybe the first about 5 or 6 hours of work, you should be able to get away from syntax error quite easily. The next one is about something called type errors. Okay, anybody explain to me what type errors really mean? Or you can give me one example. Yeah, go ahead.
To define an int and instead putting letters.
Yeah, awesome. Yeah. Basically, type errors are simply when you are trying to manipulate values in an inconsistent way. That's type errors. Okay? And we'll see quite many kinds of type errors. So type errors means you're trying to manipulate values inconsistently. Manipulating values inconsistently. And let me give you two examples. Example one. Okay, example one, if I say integer, like what your fellow student was saying, let's say integer I, but you say that it's assigned to maybe 2030. You're manipulating values in an inconsistent way. You cannot assign string into integer. Incompatible, right? Another example. Let's say I declare integer I, which is 2030. And then I say j is assigned to x. Oh, sorry, let me just say one more. And I say integer j. If I only write these two lines, is it going to compile? How come? If you don't think that's going to compile. Exactly. All right. So undeclared. Doesn't compile. Doesn't compile. Right. So these are the typical ones. I want to give you one look ahead, which we're going to dive into. Number 3. Let's say we have some class that we declare, C1, somewhere. I declare some object here, and then new C2. Let's say both C1 and C2, they exist. Okay? However, this would be considered as a compilation error if somehow these two classes are not related in the right way. And for them to be related in the right way, we have to dive into the theory of inheritance. All right? Only compiles if C1 and C2 are related in the right way through inheritance. And just for your information, what do I really mean by the right way? I can show that to you right away. Okay? The right way. That means the C1 over here is a class, and C2 over here is just another class. They are related to by we so-called inheritance relation. But in Java, there's a keyword that we're going to learn later. It's called extends. You must make sure C2 extends C1. Exactly why, we had to learn. But I want to give you some look ahead. So type errors are really the errors you guys may struggle more in this course. All right? Hopefully, all the type errors I'm going to discuss, it will not be the issue for you anymore beyond this course. Okay? Let's now go, what about runtime, right? Runtime simply means assuming that your code compiles without any compilation error. Now, the runtime is going to show the behavior of your code. So it is so important to say the following. Assuming that your code compiles, what's its actual behavior? Maybe the behavior of your code is supposed to sort an array, for example, right? Does it really do it? You gotta test it, right? Maybe your method is supposed to maybe invoke the change on another object. Does it really change the right object the right way, right? So that's really the runtime. And I can tell you, beyond this course, I would say once you pass through, this will be your second Java course. I would say passing through this course already, you're not really supposed to be struggling so much about compilation. Runtime, take my words, you will always struggle with that, including myself. Because for runtime here, we can talk about different scenario. I want to talk about it. I will categorize the runtime errors into two. One would be more like a standard, which is something you can definitely avoid more easily. For example, array index out of bound exception. Right? That's something you will encounter actually in lab, I'm pretty sure. Okay? Another thing is called null pointer exception. There are definitely certain things you can do in your code to be more defensive about having these errors, right? But to really completely get rid of them, not quite possible, because it really has to do with the logic of your program. If the logic for your program is not exactly right, you can easily run into these. I'll show you what I mean, maybe a little bit later. Another one, which you may not have seen, class cast exception. And this is something that we're going to dive deep into in the inheritance lecture. Standard in the sense that for these, all these three typical exceptions they might write into, there's a certain way you can program in a disciplined manner. You can try to prevent them as much as possible. However, what I will consider as something that's not standard, I'll say creative errors. The most valuable thing about we as a developer, as a human, is we are creative. We are able to solve problems creatively. Give me 1 minute, please, and then we'll definitely finish, okay? Creative. Okay, so that simply means the output does not meet the doesn't meet the expectation. And this is something you have to catch by J units. All right. Okay, it's a very quick clarification, but please take a look at this diagram here. Just make sure you understand the flow. All right. Thank you, and then I'll see you next Monday.